Hello again. So today is going to be an extremely short video lecture. This video lecture is all about just the exam preparation. The exam, just because I'm recording this the day after the exam, I can tell you about the exam. If you'd like to play along and practice your skills, you can take the exam if you didn't already. But on the exam, we have people make an app. The exam app was a Guess My Number, so it's just an iPhone and iPad version of a Guess My Number app. So the idea was you would start it up, it would pick a random number, you would type into this UI text field, you'd click on guess and it would tell you if you were too high or too low and to guess again. If you got it right, it would display what the secret number was that you just guessed and how many times you had to guess that. There are also icon files available to where I wanted you to give your app a certain bundle name, a bundle identifier name, and then also to use the certain icon. So it's just a silly little icon. But it was a summary of all the skills that we've learned thus far. So that's what's in the exam if you wanted to do it. What we actually did on this particular date in the class is we went over how to make a random number. So let's go ahead and do that real quick. Thought I would go ahead and record a video about it for anyone that might want to take the exam. So in order to make a random number, we just wanted to show you the basic code. So just go ahead and make a new project. So I mean, you could make just an application if you wanted, but I'll go ahead and make a it doesn't matter. Let's just make a command line tool. I just want to show you the commands that you use. We don't really need anything graphical for this. And so let's just go ahead and call it random number. And so what we want to do here is we want to just pick a random number. And we'll just print out 10 of them, right? So if we make a quick little for loop, why is my autocomplete not working? Let's say that we wanted to make just 10 random numbers and print them out to the screen. So let's say we're going to make a secret number, and then we're going to print it out. And there, autocomplete finally did something for me. Random number equals %d, secret number. There are a lot of different random commands. There's a rand, there's an srand for seeding that random number. The one that we're going to have you use is the one that the book that we have uses. And what it is it's a C function called random instead of rand. It's actually got the O and the M on it. If you look at what it does, it returns a long variable type. So a long should be a 64-bit, I believe, is the variable type. I never trust it, so I'm going to typecast it later, but I think it's supposed to be a 64-bit number. And if we were to go ahead and run this now, I'll build it and make sure I don't have any errors. Appears to be error-free, and then if I run it by hitting Command-Enter, and then I hit Command-Shift-R, I can see that it prints out Hello World, and then it prints out 10 random numbers. Now what we want to do in the exam is we want to be able to pick a random number that's in a certain range. And so in order to pick a number that's in a certain range, there are a lot of ways you can do it. But one way that you can do it is you can scale the random number that's given based on how big it might be, and then multiply it by the range that you want. So if we wanted something that's between 1 and 100, we would divide this by its potential range and then multiply it by 100. By dividing it by the potential range, we would essentially get like a clamped float, so like something between 0 and 1, and then we'd multiply it up. So the first question is, how big can these things be? If you look at them, they're usually in the billions. You can see that here's a 1 billion, What's the biggest one we've got? If we run it again, it'll give us some new ones. Looks like there's, I think I saw 1.8 billion. Oh, you also notice something interesting. If I hit build and run, I get the same random numbers. What are the odds? That's amazing. To fix that, what we need to do, let's fix that real quick. We need to call a function called sRandom. sRandom is to seed the random number. You can see that it needs an unsigned integer. If we were to just type in an integer here, we would seed it the same way every time, so we don't want to do that. Fortunately, there's a function called time. Time is also a C function. Time expects a pointer to a struct of type time underscore t. But if you just pass it in null, what it'll do is it'll grab the current time. And it returns a time in seconds since epoch, I believe. But this is a really good way to seed the random number. So now if we run it, we can see that it should pick different numbers every time we click on run. And what I was trying to do before is I was trying to figure out what is the range for the random numbers. Here's the biggest one I've found so far. This is a 2 billioner. And so you can see that if the biggest number is about 2 billion, if you're good with binary, you might be able to guess what this thing is, because you know it's going to be 2 to some power. It turns out that it's giving us numbers between 0 and 2 to the 31st power. So that's kind of one you'd expect. So it guarantees that the first bit would be 0, and then the bottom 31 bits are some random number, right? So what we would really like to do is we'd like to divide this by the size that is given to us. We could type in 2 to the 31st if we think that that's what it is, but even better way would be to use this built-in constant called ranmax. If you hold down command and double click on it, you can see that ranmax is this number right here. So actually it wasn't 2 to the 31st, it was 2 to the 31st minus 1. So maybe you saw that one coming. So it's actually this number right here. If you want to see this in decimal, you can see that it's the same number, right? So that's what we're going to divide by. So really what we want to do is we want to divide it by that so that we get a value between 0 and 1, and then we want to multiply it by whatever range we want. So if we want a number between 1 and 100, or actually 0 to 99, we do this. There is a problem with this though. Just to kind of show you, let's just run it and we'll see the problem. We have an integer math issue. You can see that my random number is always 0. That's because this does integer math. If we have a number and divide it by something that's bigger than it, it's going to be a fraction, so it'd be like 0.9 or 0.1. Since this is an integer divided by an integer, we get an integer result. 0.9 as an integer, it truncates, so it drops down to 0 every time. So one thing you could do to try to improve it is you could do this. So let's multiply it first and then divide it. Also, I hate putting numbers in code and magic numbers, so let's do this. Let's also make a pound define for our max ran value. So instead of typing in 100, I'll just put in max ran value into a pound define. And if you run this, you can see that this actually is working just fine. Now, because I'm a big old worrier, and I worry about being on a platform where long is 32 bits instead of 64 bits, you can see that random returns a long, which should be 64 bits. So it should be safe to multiply a number that's 2 to the 31st by 100 and have that not go out of bounds. But because I'm a big old worrier and I worry about being on a platform that long is only 32 bits, I'm going to explicitly typecast it. So what I've done here is I've taken the result of random and I've explicitly typecast it to be a uint64 variable type. If we look at a uint64 variable type, it's actually called an unsigned long. So maybe it was good that I did this. And so this will make sure, so 2 to the 64th, we don't have to worry about this overflowing, because if we say 2 to the 64th, we're talking about a much bigger number, right? So much larger, 19 decimal places. So no concerns of it overflowing. Another thing you could have done is you could have converted things to floating point and gone that route. This is actually more efficient by staying with integers. So you can see somebody's background. My background is C programming, so you see stuff like this in C programming all the time. Typecast it up, multiply it first, then divide. You avoid integer math issues, you avoid overflow issues, and you should reliably get numbers that are between 0 and 99 is what you'll actually get. You could hit 100, but the odds of hitting 100 are pretty poor. You'd actually have to have the value that was exactly rand max. So you have a 1 in 2 billion of ever getting 100. But it could go from 0 to 100. See if I can get a 0. Oh, there it was. I finally hit the 0. So you can see that it can go down to 0, and it goes up to 99. So if you didn't want that, right, you could add 1 to it, but we're not going to worry about it. So this is the code that I gave folks prior to the exam. I didn't want them spending all their time in the exam trying to figure out how do I make a random number that's between 0 and 100. So I just gave them this code to get started. So that's all that's in this video lecture. In class we talked about project sum. We also did a little bit more work on fraction, but I'm going to put that into the next video lecture. So if you'd like to get some practice, feel free to take our exam. It's a good little chance to get your feet wet with a little less hand holding. Cool, that's all we got.